So hello everyone, today is June 28th. We're going to continue on with chapter 10 homework. Unfortunately, the first part of the homework didn't get saved properly. I think that's why, they're going to be rolling out new laptops for us. I've had a lot of problems with my laptop recently within the past month. If I just put it to sleep, ever since that last update during class, it's been really acting up. If I just close the lid on it, the top, I have to restart it every single time. So I'm not sure what's going on with this computer. It's just something I have to work with though, until the new laptops roll out soon. With that in mind, if you need help on any of the questions from questions, I think we did 1 through 18 yesterday. Just go back to the video and it'll show you how to work them out. So I apologize for not having the PowerPoint available. It's beyond my control, though. It's some technical difficulty. So let's go ahead and get started on question 19. And once we finish this homework, we'll take a 15-minute break, and then we'll go into chapter 11. Chapter 11 is not too long. We're not going to have any homework on it. And then we'll be done because I don't want to get too far in because a lot of you will be taking organic too. And we'll go right into the next section then for that when we get there. So let me pull up question 19. Okay. So we're given this compound. It says, draw the major monobromination product formed by heating the alkane with bromine. So there is a hydrogen at this position. And remember, tertiary is more stable than secondary, is more stable than primary. So this would be a tertiary radical right there, a tertiary alkyl radical. So let me see what we're acting with Br2. So we're going to have bromine radicals going on. And to get the bromine radical, remember there's heat in here, so this is going to break apart like that. And that's how you're going to get to here. So this would be your step 1. Step 2 would be here. Step 3, then we have this radical. We have another bromine floating around. Combine. And finally, step 4 would be the final product. So that's it. All right. Any questions on that one? All right. Let's go to 20. We have this compound right here. It says, draw the structure of the organic products or products formed in the reaction AIBN with a radical initiator. So what that is going to do is going to generate a bromine, and then what's going to happen is have that. One of the products then is going to be just with another bromine. The second product, what you're going to do is you're going to have this. Yep, you're just going to move the double bond. If you do that, you'll be left with this here, and now this one can go get a bromine. So you have two products. Here's one. Here's your second one. So I'm going to leave that up. I'm going to go read 21 to myself. All right, so 21. It says complete the mechanism and products of the reaction of one butene or one ene. So what would that be? That'd be this right here with a trace amount of HBr in light. So what this is going to generate is bromine radicals. Use curved arrow bonds, atoms, and electrons to complete the mechanism. Let me see. So if we're gonna generate that bromine, we will have, let's just draw what they want. So we have this, and this hydrogen. Carbon here. Oh, obviously we're gonna have this. Here, no. So yeah, that radical right there. And then they want us to show resonance. So sorry about that. I should have put the double bond there. Step 4. And that radical can move, so we'll just move that. So we're moving the double bond. And they said this is structure B then. Radical there. Then they want step 5. So we'll do step 5 then. All right, so that should take care of that problem. Well, they want step 6, I guess, termination step. Will just be, we'll put it right up here. The bromine radical, and then you have your bromine that attached. Actually, okay, I'm going to use this. They want you to use this one. So we're going to use that one. All right, so that should do it. All right. I don't see any questions. We'll go on to 22 then. 22 says for a radical reaction involving an HBr and propene, sort each reaction step into initiation, propagation, termination. So we'll go over it stepwise. Initiation. This is where we have this peroxide. We have this. If we form that, we'll have two of these. Then that can come down here. We have Br radical. Now they want to talk about, we might use 2 slides for this one. So we have propagation. Or if we have that, bromine. Have that. The propagation will be, we take the same thing we just made. I'm just going to draw the carbons. We can add it to HBr out there. Going to form a bromine radical, so we have our propagation step. So I'll let you copy that down. Then we'll move on to termination. Termination is just combining the radicals. All right, so let's go on to termination. So this is our final step. And terminating, we're just combining radicals. So if we have 2 bromines, they can combine. Let's see, if we have, just draw it as a straight chain. 1, 2, 3. This radical, this can combine here. Finally, we have this. It could also combine with another one of these things. So that would be your termination steps. So that was, what number was that? That was 22 continued. All right. And let's just remember here, we have this in the next question, 23, is going to go on this concept. So it's going to be a peroxide. We're going to generate bromine radicals. So we're going to have some bromine radicals. So I want you know, so you know where the bromine radicals are coming. So if we have some peroxide, it generates OR radicals, and they can react with HBr or BRBR, and they can form, you know, bromine radicals. So I wanted to show you, you know, where these bromine radicals are coming from. In this case, we're using HBr. So let's do 23. We already established where the bromine radicals are coming from just our previous question, 22. My structure is not showing up entirely great, but it says I have, let me see, pentene, 1, 2, 3, 4, 5. At the 2 position I have here, 2. All right, so I have it done correctly. And, wants us to draw the major and minor products. Here. Erase that. It's not letting me erase that mark for some reason. Let's just see if we can use it. Oh, there it goes. Or that radical here. Oh, this is not the right mechanism, so I apologize for that. Let's get rid of that. Let me think about this for a second. Two, that's at the 2. So that. I could also take this and go here. This would be tertiary. This would be a secondary alkyl radical. So then there'd be some hydrogen radicals out there. You just combine them. So these will be your products. Because if you recall, let's see, we have the there will be some hydrogen radicals out there too. That's why we can do this. So these are your two products. Oh. I'm going to put a 1 by, this is your major product. Here's your minor. And why is it major? Because you have a tertiary versus a secondary. All right. Hopefully that was enough time to put in that answer. Let's go to 24. The 24 says predict the major products. So we have the peroxide. We're going to generate peroxide radicals. Now in the presence of HBr, we're going to get some H radicals and some Br radicals. And then if we have this compound right here, now where are we going to put the major products will be here because we're going to have the radical here, right? This is a tertiary, alkyl radical. So if that's a tertiary alkyl radical, it'll combine with a hydrogen radical, and we'll get the following product. All right. I don't see any questions, so I'll go to 25 then. 25 says we have a compound, we react with NBS, and we get two products. see. And NBS is N-bromosuccinimide. That's so we don't get competing reactions. So we have this. Let's just draw. Let's just think about what we're going to do here. This is NBS. No, we're going to get a radical here. Just trying to think about this. Okay, we could add it right here. Okay, I got it now. So we could add this here. If we add it there. Just trying to think about this for a second. These two reactions. So I got it. So in one reaction, we're going to get this. Another reaction, we're going to get this. And then it wants us to react with a strong base. So recall that there's hydrogens here, so it's a really strong base. I'll just call it SB for strong base. It can do this. And that can be a good leaving group. So it's an elimination reaction. So this can go further. It's a yield. It's right here. So compound 1, we have compound 2. So with this one right here, let me see. You know, we're not going to be able to really do a strong base on this one. I mean, can't. It's just too bulky. This is a bulky strong base, so this is not going to be able to to get in here. If we have a hydrogen, let's see, 1, 2, 3. If we have a hydrogen here, this is not going to happen because it's bulky. Let's think about something. Yeah, so that's it. See, that was 25. Let me pull that back open. Yeah, so that's it. Yeah, that's it. And so I'll leave that open. And we'll go to 26. So let me see. Someone's saying right there with the bromine, it's wrong. Let me recheck that. Oh, let me draw this over here. We got this. We got this. Try putting the bromine right here. See if that works. Okay. Okay, good. So that worked out. So thank you for letting me know that. So let's go to 26 then. 26 says construct a 3-step synthesis of 3-bromocyclopentene from cyclopentane. So we know we're going to start with cyclopentane. Let me see. I'm going to start with this. We know we're going to have, in step 1, well, step 1, they're saying it's a product. For the reagent 1, we'll call it R1. You know, we're going to have bromine. We're going to have to create some type of bromine radicals. We'll use HNO, some type of light. Then, you know, we're going to create some type of radical here. This will come here. Doesn't matter which hydrogen you use. Step 1 will generate something like this. Let's just keep it like a baseball plate. Put the bromine here. Now to get rid of it, we can use a base. In this case, we'll call this R2. The base will be, and this is a bulky base, CH3. Now that base will, you know, either remove this hydrogen or this one. It doesn't matter. They're both equivalent. Come here. So we have an elimination step. So our step 2 product will be this. Here. I just want to see what I did. I know that's right, but I just want to see what I did on a previous question. All right, so then the NBS, we're going to abstract a proton. So we're going to extract some type of proton here. Let's just put this where they have it on their screen. This is going to get abstracted. I'll put it here. And once we have that radical, we can react with bromine. So that makes sense. Reagent 3. There we go. That bromine there, we can put it like this. That's it. So that's 26. All right, let's go to 27 then. 27, we're going to be doing some repeating. So it says, okay, we start with ethane, has 6 hydrogens. And so what are we going to do? We're going to have to create some type of bromine radical and do this. We'll call R1. We'll have Br2 H nu. If we have that, we have the abstraction of the hydrogen will happen. And we can put a bromine on there. So we'll have a bromine. Should be a 2. And let's redraw that. So we know that the other hydrogens are there. But what's going to happen then is for reagent 2, well, this would be step 1 product. R2 will have to be some type of base. So we'll put this. You can see now we have ethene. This is step 2 product. And then we just continue on. Then we have to add reagent 3, which is Br2. Create our bromine radicals. We'll put a bromine here. So step 3 product will be this bromine. Then we have to use another strong base. Oh, negative. So what's going to happen is this. Another elimination. And finally, we're left with the acetylene. And obviously, there'd be a hydrogen on each side. Well, that should be that. All right, so that's 27. Let's go to 28. 28, they give us this. And then they say we have to make this right here. So we're making that. So we have 2 reagents, R1, R2. Let's see something real quick. So we have a hydrogen drawn in either case. So this is a bulky base. I'm going to take this. It's going to release. Where would I put that at? So this will be your step one. And that would be your last step. So this would be your step two reagent would be all right, that's it. So we'll come back at 11:15. I will load this up. Like I said, I don't have the first part, but then we'll come back and we'll go on to chapter 11. All right. Hopefully everyone enjoyed their break. Do you have any questions so far? All right. Let me go ahead and share my screen. We're going to go right into chapter 11. Chapter 11, it's pretty short. So it's titled Synthesis. So you can imagine, they're going to want us to think about different ways we can synthesize different compounds. It says solving a synthesis is straightforward when only one reaction is needed. Let's say here we'd only need Br2. Think about this. Let me get my pen out. Laser point. Oh, I know what I have to do. Sorry about this. I have to enable the editing. I will reshare my screen now. Oh, it says I'm still screen sharing, so I'm good to go. Now I can get my pen out. So you can imagine, if we have Br2, and we've seen this before where we form this will be leaving, and then that Br can come in either here or here. So it says it's logical to review the two-step synthesis strategies from the previous chapters. So it's a good idea to always go back to the previous chapters. You'll have a little bit of a break. Once we get done with chapter 12 or 11, I don't want to go into 12, only because I don't think we'll have enough time to get through it all. So whenever we're done with 11, that will be it. And then we'll start chapter 12 on Monday. So it says logical. So during that time, I know some of you have finished the final exam. Go ahead and review the previous 10 chapters. It'll help you out as far as going on to these different further chapters in the book. It says moving a functional group from one carbon to the next. So here we have an elimination. Eliminate that with some base. And it's gone. And then we have the addition. So here we need to obtain the Zaitsev alkene and choose a strong base accordingly. And then the second step must be the Markovnikov addition. So here they're showing us what base. And if you want to go if you want to go back, if we use HBr with the peroxide, we can go back and get rid of that double bond, can't we? And we can put the bromine back on. So, like if we use a bulky base, then we're going to take it from this side here. That this T-butoxide, it's not going to be able to take this proton here. It's going to have to go here for this one. So depending on your base size, this is just this, and this would be this. So there's a size difference here, isn't there? So it's going to preferentially go here. Get that one there. And afterwards, we're just going to brominate it with HBr in this case. And here we can use HBr with our peroxide to generate this bromo alkyl. So depending on what you want to make, depends on really the reagents that you're going to use. I'm just going to leave this up here because I know you're looking at this and it's probably your first time, so I think it's a good idea just to look at it and to try to understand what's going on. Now, remember, you have a smaller base here, so I'll just call it smaller base, LB for larger base. Here we're adding the bromine with just HBr. Here we're adding the peroxide to put the bromine here. If we didn't have this peroxide, we'd be putting the bromine here. That's why we add the peroxide to it. So it says functional group transformations, pay attention to the regiochemistry. So depending on where you want this, alcohol group to end up depends on which groups you're going to use. All right. So we also have to know how to apply a two-step strategy to move the position of a pi bond in an alkene. So for the first reaction, we need to add the proton and bromine to the alkene. So we have an addition. For the second reaction, we need to do an elimination. So they want to do elimination right here instead of right here. That way we can form this double bond. This will be elimination right there. This is, again, the reagents we choose depends on the regioselectivity we need. This takes a proton, positive charge here. That bromine can go in right there. We have a tertiary carbocation. That T-butoxide is a bulky base. That's why it's taking a proton from this side instead of right here. It's easier to abstract it. It's not as there's not as much stuff in the way. Now, if we wanted to use a smaller base, we'll take it here. Oh, we'll take it here. This is a smaller base right here, so this would be a smaller base. We can take that proton here, and we go back to what we had. Likewise, we'll get the bromine added to this side if we put some peroxide in there. Now, if we use a bulky base, we're not going to take this proton our way. We're going to go for this one right here. All right. So it says this two-step sequence is needed to convert an alkane to an alkene. We can do some radical bromination. We'd have this. Then we can do an elimination step. If we put in a bulky base like T-butoxide, we can get rid of this hydrogen right here. We have our elimination step. Let's see, we would then be able to convert the double bond to a single bond or a triple bond. Now, if we want to go right from this to this right here, just use this condition. So from a triple to a double bond, and this is stuff that we've learned already. Use the H2 with the Lindlar's catalyst. This will get you a double bond. You can go straight from here to here with these conditions. Well, yeah, it was H2 and platinum. Yeah, I was thinking it was either palladium, but I'm pretty sure it's platinum. here we can, I want to erase some of this stuff here. Here we can go from the single bond to a double bond by creating radicals, right? So if we have this radical, we can create the double bond, and we can go backwards because we'd have this bromine here, and all we have to do then, we'd first add the, we'd add the bromine. Once we had the bromine there, then we just have to eliminate it with the base. So that base will come in here, form that double bond, and we're here. And we can do it when we use a stronger base to go to here then. Again, we'll have to add the bromine there to have a good leaving group, and then we can go to the triple bond. So these are just some things to think about, going back and forth. All right. I just want to give you some time to think about that. That's why I'm taking my time. So for some transformations, it may be necessary to tamper with the carbon skeleton, add or remove carbons. With the synthesis, when a synthesis requires a carbon skeleton to be altered, you need to be able to recall the reactions that can add or remove carbons. Most reactions learned so far only change a functional group or change the location of it. So what they're saying is, you need to pay attention. We have 4 to 3 to 7. We're changing the number of carbons. For the time being, we know this reaction will have to be used when we need to add carbons to a compound. How does this work? So then we have 1, 2, 3, 4, 7. You can see that right there. So what does that kind of remind you of? That, SN2, right? Substitution nucleophilic bimolecular. So we also have also learned a way to decrease the number of carbons in a molecule. So here we're going from 1 with 5 down to 4 and 1. And they're saying use these conditions right here. Remember, we break that bond right there. We form the aldehyde. And this will be the last slide we do today. So to approach any synthesis problem, first answer these questions. Is there a change in the carbon skeleton? Is it gaining or losing carbons? Is there a change in the identity or the location of the functional group? It says solving a synthesis problem requires the recall of all the reactions learned and working through many examples. So again, we'll stop right there. And have a great day. We'll see you tomorrow. And we'll finish this chapter, and that'll be it. So once we finish it, you'll have free time until Monday. And if this is the last class you're taking with me, I hope you enjoyed it. I've enjoyed teaching you, and good luck with whatever endeavors that you choose to do.